One of the important things is that you are comfortably following a protocol. So you have your protocol. This is in the practical manual that you've got on the first day. If you haven't got that, please go on to, I think I've sent you in an email, the link to the manual. Please print it out. Yeah? So you can follow a protocol. You are comfortable in using pipettes. So that means the automatic pipettes as well as the larger pipettes with the squeezy ball. You are comfortable in using a spectrophotometer and measuring samples in the spectrophotometer. I'm looking over here because you're doing me such a big favor. You always go like that. So I know that everybody should go like that. No, you do that. That's good. I like that. So you have done that. You have done all these things. You need to be comfortable in presenting your data. Yeah. That means comfortable in calculating some data, comfortable in presenting a graph with the axis labeled, with all the right units attached to it. And then you need to also be comfortable in interpreting the data. So, i.e., do a little bit of descriptive statistics. Mean, standard deviation, and standard error of the mean. And again, these are things that we've done in the past. Okay, so if you are not comfortable with these things, you still have 16 hours, 18 hours rather, to familiarize yourself with these things. Yeah? But it's nothing new. You have done everything, and there's nothing to worry about. You do not have to provide a big write-up. All you need to do is give me the graph that you used, give me the calculation that you used. Preferably, everything is labeled with your name, maybe even with your login, and with the enzyme spec. What this means, I will tell you in a minute. Okay? So no big write-up, no introduction, summary, and God knows what. Not interested in that. If you want to do it, fine, if I can't stop you. You are allowed to bring in notes from previous practicals as well as from your studies. So that's not a problem. You can't phone a friend, although I doubt that a friend would help you in this case. Yeah, so it's not really anything you need to worry about. Okay. Any questions about that? What happens if you fail? Well, tell you what, we don't discuss that. Not at the moment. Because I'm absolutely confident that nobody will fail unless they decide not to turn up. So far, in previous years, the average for this practical, for this assessment, was around 82%. That's the average. Can you do that? Can you beat that? Okay, I will make a note of that, but you don't want to do that. Yeah, I know. Can you beat 82%? Okay, what did Barack Obama and Bob the Builder say? Yes, we can. Okay, good. Excellent. So what is this? What are you going to do in this practical? So the aim of this practical is actually to identify and to determine an unknown protein concentration. Unknown protein concentration. Using a spectrophotometer. And we said we can easily do that if we, for example, have the extinction coefficient for this protein, because then we can use the Beer-Lambert law. So absorbance equals concentration times the path length in centimeter times the extinction coefficient. But we also discussed what happens if we don't have the extinction coefficient. And we said if we don't have an extinction coefficient, we can sort of wiggle around this problem by using a standard curve. So what we do with a standard curve, just as a revision, what we do is we just simply measure the absorbance for well-known concentrations of protein. So for example, if we have on the x-axis defined concentrations of protein, and this could be, for example, in milligram per milliliter. That's a perfectly valid concentration. And we measure the absorbance for these well-known concentrations. We might get a straight line. We might get a standard curve for that. And every line is a curve as well, so instead of saying standard line or something like that, it's a standard curve. And from this standard curve, then, we can easily read off our unknown concentration. Let me do that in a different color. So if we say, for example, our unknown concentration of the protein had this absorbance, we then just simply can equate that from our standard curve and say this absorbance here that I just indicated is equivalent to this concentration from our known standard. Does that make sense? Yeah? So, this experiment basically is made up of 2 bits. First is you need to generate your standard curve. And the second part is if your standard curve, if your standard line is a nice straight line, then you can use that to measure the unknown concentration. So, how are we going to do that? Well, for the first part, we take a total of 8 samples. These 8 samples here, 1 to 8, 1 to 8 make up our standard curve. And these are the test tubes, 1 to 8 here. You have oh, I cut that off apparently. You have a standard, you have a given concentration of BSA, bovine serum albumin, and this concentration is 10 milligram per milliliter. And you add, for example, in test tube 1, you add no BSA, you add 1 milliliter of water, so your total volume is 1 milliliter. Yeah? You then take this 1 milliliter and add 7 milliliter of the bi308 reagent. This bi308 reagent is a compound that forms a complex with proteins. When we did the BSA experiment in the molarities practical, we measured the BSA at 280 nanometers. That was in the UV range. It is not terribly accurate. With this bi308 complex, the protein, actually the solution, becomes colored. It becomes very nicely bluish purplish color. So it's much easier actually to spot what's going on. Okay? So to this one here, to the first tube, you add 7 milliliter of this bi308, and then it's very important that you mix very, very well. Mixing is the important thing here. And you've got this whirly mix, I think, on the bench, where it goes, when you put your tube on it, it goes. Yeah. So you can use that as long as your solution stays inside the tube. If it goes like, yes, blender without a lid in the kitchen is absolutely fantastic, especially when you do beetroot juice. Yeah, not recommended. I've done that once, learned my lesson. So mix it very, very well. Okay? So in the first tube you have no BSA. Can you tell me what the concentration of BSA is in milligram per milliliter? 0. So you can already fill in this table here. Okay, in the second tube, what is your concentration of BSA? Sorry? 10? 1? Okay, let's see how we can actually calculate that, because that might get interesting for later. What do? We take 0.1 milliliter of a 10 milligram per milliliter solution, and our total volume then is 1 milliliter. Bless you. Okay, so here I took the volume. Here I took the concentration, and here I took the total volume. Okay? So if you try to do that here, what would you get? 0.1 times 10 is 1 divided by 1 milliliter, so you have 1 milligram per milliliter. Okay? Tube 3, how much have you got in there? 2. Tube 5. Tube 8. 10. Okay, so the rest you can do yourself. Are you happy with that? So what you can actually do now is, once you have done 7 milliliter to each one of these tubes, to each 8 tubes, you wait 30 minutes. So you mix, you wait 30 minutes, and then before you start measuring, my advice would be to label your cuvettes 1 to 8. You don't need any quartz cuvettes. You can use just simply plastic because we are not using UV light. You label them 1 to 8 and you put them in the order of purplishness. What does that mean? So, in the first tube, there is no BSA. So the solution will be more or less, let me see if I can get a nice color. Okay, so in the first one, the first tube, there's just a little bit of a tint of blue, just a little bit. Because the blueness, the purplishness, is this a word? You know what I mean. The purplishness depends on the BSA concentration in it. So in the second tube, it's getting a little bit more blue. Third, even more blue. Fourth, darker blue. Fifth, even more dark. You get it? Yeah? If this is not the case, if you've got light blue, dark blue, light blue again, then there is something wrong. But you can very easily spot that. It should get more and more blue, purple, dark, the more you go up. Yeah? So these are your 8 tubes of your standard. At the same time, when you set up your standard, you also set up your unknown concentration. What does that mean? You will be provided with a tube, go away, with a tube which has just a letter on it. This letter will be A, B, C, D, E, F, and G, I think. Please take note what letter this is, because these are all different concentrations. So you get one tube, either A, or B, or C. Yeah? Just one tube you get from, or one little sample. From this sample, in 3 tubes, you take 0.2 milliliter, 0.8 milliliter of water, and you've got a total volume of 1 milliliter. So you've got these 3 tubes, unknown 1, unknown 2, unknown 3. All 3 tubes should contain the same amount of protein. Yeah? Are you happy with that? You then treat that exactly like you treated your standard. That means you add to these 3 tubes again 7 milliliter of the bi308. And my advice would be, prepare everything at the same time. So you have 11 tubes, 8 for your standard, 3 for your unknown sample. Yeah? You then measure your standard, the absorbance. Now, the first tube that should not contain any protein, that is the sample that you use to zero your spec. Or blank the spec. Yeah? And then you just simply put in your samples and simply measure the concentration, measure the absorbance. So we have 1, 2, 3, 4, 5, 8, and oops, made a mistake. This would be 6, 7, 8, 9, 10, something like that. And this is the BSA concentration. So you need to label your axis, and this is in milligram per milliliter. Needs the unit. A graph without a unit is like a party without booze. You just don't do it. I was about to say something more sinister, but you know, you're all young and impressionable, so I'm not saying these things. And on the y-axis, you measure the absorbance. What is the unit for absorbance? No unit, so don't put in any unit, right? Now, should your graph actually, should your standard curve, should it go through the origin? Why? You're right, yes, but why? Because the zero concentration of the BSA you used to blank with. So therefore, 0 milligram of milliliter BSA should have an absorbance of 0. So it should go through that. It should look like that. Yeah? There's a good chance that you probably see a little bit of deviation. What you actually can do is, just by eye or with the ruler, try to find the best fit. Do me a favor, don't do the drawing by numbers thing, you know, where you do something like that. Don't do that, yeah? If you find massive outliers, indicate that and say just simply that is an outlier. I don't believe this number. If your graph only contains outliers, something like that, yeah, I've seen that, there's something severely wrong. You can check if you order according to bluish. This would be a typical example of, being the blue purplish color all over the place. In this case, you have enough time to repeat the experiment. Yeah? If that happens, talk to me. But ideally, your points should be on a line, more or less. The better your experimental skills, the closer these dots on the line. Okay, happy with that? So this is your standard curve. Now you measure also your unknown samples, and don't forget you have 3 unknown samples. So you would get probably three different readings. This is what I would expect. And for all 3 readings, what you can do from the standard curve, you just simply try to figure out what is the correspondent concentration. So something like that. Yeah? And what you can check is, obviously, your unknown samples could be, for example, that's your unknown sample. In the blueness, it could be, for example, between 4 and 5, let's say. So you can immediately see where your unknown sample is located. And that helps. If it is all of a sudden, very pale, there's something wrong. Maybe you forgot to put a bi308 in it. Maybe, bless you, maybe you forgot to put the protein in it or something like that. So immediately you see that there's something wrong. But we hope that there is nothing wrong. So what you get now here is 3 different values for your protein, for unknown protein. Yeah? And how can we translate that actually into the sample, the original sample? Let's remind ourselves what we did. We used 0.2 milliliter of an unknown sample and had that in 1 milliliter. Yeah? And this gives us, say, something 5.7 milligram per milliliter. Does that make sense so far? Yeah? This is basically what we have done. We don't know the unknown concentration, but it is analogous to what we have done here. Bless you. Yeah. There we had 0.1 milliliter. For the unknown, we take 0.2 milliliter. For the standard, we had 10 milligram per milliliter. For the unknown, bless you again, we don't know, but we have a total volume of 1 milliliter. So it's basically exactly the same, but in this form here. So all we need to do is we need to look for this unknown sample 1 And this is unknown 1 equals 5.7 milligram per milliliter times 1 milliliter divided by 0.2 milliliter. Okay? And you do that for each one of the unknown samples that you get here. Are you happy with that? Each one of the unknown samples. So you get a concentration for U1, U2, U3. From this, you calculate the mean, what did I say? Did I say the sample? The sample standard deviation. And the standard error of the mean. Now, people last year asked me, do we have to do that for all 3 samples? And I thought, not entirely sure what you mean. You do that for the 3 unknown samples. And then the student said, yeah, but do we need to do that for all 3 of them? WTF. Have no clue what you're doing. You know, it's just the 3 samples. For heaven's sake, do that. Okay, do we have to do that for the standard curve? Okay, how do you calculate the mean of this standard here? I asked the student. And I went away and said, oh, you can't explain things. Okay, I'm a bad teacher. Right? You get it. Yeah? So you know exactly what you need to do tomorrow. The write-up, as I said, is ideally it is 2 pieces of paper, each with your name. Also log in. Please do me a favor, write so that I can read it. Right? And the login is because we have, I think, 5 people by the name of Smith. So if somebody writes down Smith or Jones or Davis, yeah, right. Who of the 5 is it, please? And instead of trying to do a sort of a criminal investigation with comparison of handwriting, if you just put down your login so that I can read it, problem solved. I want you to put down which enzyme you used, so A, B, C. So because all these enzymes have different concentrations, or proteins have different concentrations. This is to stop you from cheating. If everybody had a concentration of 10 milligram per milliliter, you very quickly would have figured that out, wouldn't you? So all of a sudden, especially in the afternoon group, they would all get the right values without doing any measurements. We don't want that, do we? No. On the first page, and this would be preferably a graph paper, which you get in the teaching. This is your graph. Axis labeled and units. And I want this really to look professional. Remember, you are starting a professional career now. and the presentation of your results need to look professional. I don't want your write-ups to look like the dog regurgitated it, and peed on it, and then, slept on it. Doesn't look good. The second page, and here you would have indicated the 3 samples. And on the second page, ideally, you have your calculations. Present a nice table. U1, U2, U3, absorbance, for example, equivalent to BSA milligram per milliliter, final concentration, for example. It's a nice table. I can immediately see what's going on, and then you do your calculation. Mean, bless you, standard deviation, and please show me how you did the standard deviation. You've got the equations, and it's only 3. It's only 3 data points, so you just simply say x u1 minus x squared plus u2 minus x squared plus u3 minus x bar squared divided by how many? For sample? For sample it's 2. For population it's 3. Yeah? Divided by 2, and we do the square root of that. That gives you the standard deviation. Okay? And for the standard error of the mean, we'll just use the standard deviation divided by the square root of 3. So SEM S divided by square root of 3 in this case. Okay? It's pretty straightforward. Now, last year, we had people who were in tears. Why were they in tears? Because what they discovered was that for their absorbance of the unknown sample, they got U1 equals, I just make something up, 0.54, that's the absorbance. U2 equals 0.54. U3 equals 0.54. Can you do the mean? 0.54. Can you do the standard deviation? It's 0. They started panicking. My standard deviation is 0. What shall I do? What would you say to them?
It's not deviating in the first place.
It is not deviating in the first place. What does that mean for your experimental skills? You are bloody good, right? Stop panicking. If your standard deviation becomes really high, then there is something wrong. But if there is, there is no standard deviation, if it's 0, no reason to panic. It's good. Okay? So please don't panic tomorrow. No panic in the lab. Please don't. No, it's not good. I can't deal with tears. I'm a bloke. Right? Okay, do you have any questions about that? Practical. 9. Very good. Good man. Sorry? You're using 1 centimeter cuvettes, yes. Yes. Sorry? Yeah, of course you can bring the lecture notes. Yeah? Okay, we have a short break and then we come back at 3 and continue with the pH, okay? Equals square root of the sum of divided by n, by the number of observations that you have, right? That is population. And just 15 minutes ago, I told you use the equation for the sample standard deviation. And the sample standard deviation is S equals the sum of these things divided by n minus 1. So that is the sample standard deviation. I have given you in the protocol only the population standard deviation, but I think in hindsight it might make more sense to calculate it with the sample population. Yeah? Nevertheless, I will not penalize you for using either. Yeah? And it highlights a fact that we are going to discuss closer to Christmas when we really dive into statistics and presentation of data. It presents a problem. Which should you use, population or standard? Sometimes it's absolutely plain obvious. In this case, it's not. So I would prefer if you use the sample standard deviation with the n minus 1, but if you use the population standard deviation, you are not getting penalized. Yeah? Another thing that people asked me was, what is this with this table where I said U1, U2, U3? And I said, ideally, what you want to have is the absorbance here. So you get 3 different absorbances. Ideally, you get only 1 absorbance if you are very good, but you probably get 3 different ones. And then I said, equivalent to BSA. And what I mean by that is actually, when you look at your graph, absorbance, BSA, milligram per milliliter, what this actually means is this one here. Yeah? So here it might be, as I said, it could be 5.7 milligram per milliliter, 5.6 milligram per milliliter, and 5.8 milligram per milliliter. That is what it looks like. Oops. This is what it looks like on the graph. That's this one here, what you read off. But this is not actually what is in your original tube. Remember, in your original tube, you just used 0.2 milliliter of that in your original tube. Yeah? That's why we do this conversion where we say this 5.7 divided by 0.2. This gives you the final concentration. This is what was originally in tube A, or tube B, or tube C. Yeah? So that would be here, 5.6 over 0.2, 5.8 over 0.2. Does that make sense? Has that clarified everything now? Hopefully. Clear as mud. Okay. Yes, good. Happy with that? Bob the Builder? Yes, we can.